All right, so thanks, Christoph. Thanks, Marco and Peter. It's my pleasure to introduce you to Marco da Silva, Principal Roboticist at Boston Dynamics, who is going to present us some spot applications. Thanks a lot, Marco. Off you go.
Thanks. Hopefully you guys can hear me okay. I apologize for the back-to-back Marco talks, but my name is Marco da Silva, and I'm a principal roboticist at Boston Dynamics. So today I'm going to talk to you about how our quadruped robot Spot is getting applied to solve real-world problems. So it's a pretty short talk. Should have plenty of time for questions at the end. So when we set out to make Spot into a product, we decided to build a platform that could be quickly adapted to particular applications. So before we built any particular application, we built an API that encapsulated Spot's mobility, autonomy, and manipulation capabilities to give partners the ability to program their own solutions to problems that they understand best. So the idea is that we understand the robotics problems and you, the partner, understands how to solve the business problems. So this video is from the archives and it's already quite old, but I chose it because it reminds me of how fun it is to get out in the field with Spot. So here, Spot chews through a grassy hillside, it goes through some dirty New England snow. And these are all things that were really hard 11 years ago when I started at Boston Dynamics, and now they're pretty routine. But each time we get into the field, we see a new challenge conquered by Spot, and that's one of the exciting things about being in this space. So in addition to software APIs, Spot's also designed as a physical platform to carry a variety of sensors. So it has 2 payload ports on the back that provide Ethernet and power for your payload. Further, there's a rail system to make it easy to attach your payload. So our customers have leveraged that to attach all sorts of sensors to Spot, whether it's 360 imagery, gas sensors, thermal sensors, 3D point clouds. All of this extensibility has also been baked into our ARM design as well. So when you get the ARM, you also have a payload port at the gripper and mechanical mounting features that let you mount sensing payloads at the end of the ARM. So I'm going to show a series of videos showing applications of Spot. So one of the biggest use cases has been digital twin creation. So we have a partnership with Trimble that's leveraging Spot to speed up laser scans of construction spaces. Even without autonomy, having a moving tripod with knowledge of how it moves vastly speeds up the time it takes to scan a site and post-process the data. Construction sites are quite challenging from a mobility and autonomy perspective. If you think about it, there's all sorts of uneven concrete terrain, rickety stairs, and it changes a lot. But we've done well enough in that space to make it one of our fastest growing use cases. Spot was really designed for industrial spaces. It can walk around factories with all their terrain, like graded floors, open riser stairs with ease, without crashing into things. And our partners are, leveraging that to build payloads to inspect equipment and plants. I think Peter did a good job of motivating all this in his talk prior to this. But these plants have all sorts of assets that need regular monitoring, and these quadruped robots are capable of getting that data on a regular basis. From a robotics perspective, we've had to make major strides in perception-aided mobility to enable locomotion on things like, graded surfaces or open riser stairs. So National Grid is a customer of ours that's been using Spot to inspect facilities that are off limits to humans to plan maintenance and shorten their downtimes. They've also been using Spot's autonomous capabilities to take thermal pictures of transformer equipment in a HVDC facility. Although it looks kind of tame, gravel surfaces can be quite challenging. I think Jesse Grizzle mentioned that this morning. You're constantly slipping. So that took a little bit of work to get that working well, but that's pretty stable now. Outdoor autonomy is also another challenge. You can get you can get pretty far using the built-in sensors on Spot, but we're looking at adding additional GPS sensing to enable more robust outdoor autonomy. So Cognite is another partner. They've been piloting a solution in a couple of different locations, including the shipyard you see here. They're one of a number of partners that are kind of putting their own pieces of the solution at various levels in the stack. So not only are they working on things like outdoor autonomy, but they're going all the way out to the interfaces, having custom operating interfaces for Spot on mobile devices as well as the browser, all integrated with data review tools. So this slide gives us a more detailed look at the ecosystem we've bootstrapped with Spot. So out of the box, all the robot comes with is the sensing and actuation that it needs for mobility and manipulation. So we package that all up in an API that consists of gRPC services that communicate with the robot via network connection. So there's a layer of core APIs that give you basic robot info, let you command it to move, get basic robot state information. And then there are higher level APIs that let you program autonomous behaviors with the robot. Finally, there are payload related APIs that let you expand Spot's sensing capabilities. We offer Python and C++ SDKs, client libraries for developers to get working with these services quickly. Some customers have built their own client SDKs in other languages such as C#. Outside of the software, we've also created a kind of a family of payload products to jumpstart customers looking to build a solution with Spot. So these payloads add sensing, compute, and comms capabilities to the robot in a way that's well integrated with it. So for example, the Spot Cam provides a quick way to add color imagery, high optical zoom, lighting, speakers, microphones, and thermal imagery. The Spot, in a package that's meant to survive, on a quadruped robot. These robots will be in dirty environments, they'll fall down, so the payloads have to survive just as well as the robot does. And on top of these, kind of building block pieces, we've built end-use applications that let the people operate the robot remotely from either an Android device or web browser. This is for manual operation or collecting data autonomously. So the API was designed with a number of advantages in mind. So we wanted the API to be secure. Our customers are operating the robot in sensitive facilities such as nuclear power plants. They really can't afford to have an insecure device wandering around their facilities. We want an API that was flexible so that customers could pick their own favorite tools for the job, be it in Python, C++, C#, Kotlin. Finally, we wanted the API to be extensible. So if you plug a sensor into Spot, it ought to look like it came with Spot out of the box. And if you go to dev.bostondynamics.com, you can see we've put a lot of effort into polishing the documentation around our API, as well as creating examples to get developers up and running quickly with these API services. So now that I've described the Spot platform, let's talk about applications. I'm going to focus on most of the talk on two prototypical applications of Spot. So one is remote inspection. Spot is placed in a dangerous or hard to get to location, and an operator manually drives it around to do a job, like looking for potential problems in the plant. This application is more or less supported out of the box with Spot, provided you have communications to the robot. The tablet interface, was designed to be easy to use for most operators. It provides decent situational awareness, again, with the base cameras of the robot, but also with payload cameras. And then we've also designed it to be tolerant to high latency environments. So this video here is just showing our touch to go interface. And the idea there is, you command the robot every 2 meters, every couple of seconds, and it navigates around obstacles itself. You don't have to worry about crashing into things. And this lets you deal with scenarios where you don't have, perfect high bandwidth comms to the robot. To support a joystick driving mode, user would have to have kind of 10 hertz feedback loop operating, and that's not always possible. So here are some more examples of remote teleoperation. So this first video on the left is of Mark Raybert, our chairman, driving a robot in our old office building in Waltham, Massachusetts, while he was sitting in business class somewhere over Chicago, using the plane's Wi-Fi. So the robot was actually on LTE communications, which gave it free reign of the office. And Mark was using the plane's Wi-Fi. Internet on the plane isn't great. It's pretty terrible, but he was able to do a lap of the building. There were people walking around. It was during work, but it was perfectly safe. Spot didn't crash into anything, despite the poor communications. If you go on the internet, on the right here, you can see people, SpaceX fans, have been taking pictures of rocket launches and noticing, certain four-legged robots inspecting crashed rockets or successfully landed rockets, wherever the case may be. And there, the operators are sitting in a nice air-conditioned environment 2 miles away from all the danger. Rockets are quite dramatic in terms of environmental challenges. So the other prototypical application is autonomous data collection. So there are two services that operate together to enable this application. The first is a service we call GraphNav, which provides mapping, localization, and autonomous navigation functions in GPS-denied environments. And once you've built that map with GraphNav, you can use the mission service to encode smart behaviors that accomplish tasks on that map. So this video on the left is an example where we mapped our old office space in Waltham and collected spherical imagery throughout the office. Basically, at each one of these blue dots, we took a 360 panoramic image. There's some purple frustums there where we took a zoomed in PTZ image. But all of this data was collected automatically using our autonomy services. This video shows the recording process using GraphNav. So an operator kind of drives Spot through the environment to record a map. The principle of GraphNav is really semi-autonomous operation. So the robot is allowed to navigate in corridors of the space that exist in the prior map. It can navigate around local obstacles or reroute through alternative paths in the graph. But it's not going to go explore unmapped spaces on its own. Given the current limitations of perception in particular, we were worried about robots wandering into water fountains or off the side of a construction site. And so this is really more appropriate for kind of safety critical applications that you find in industry. So now that we have all these pieces where you can teleoperate Spot, it can do so autonomously. We're building an end-to-end solution with Spot that we can offer to end users, such as operators at industrial plants. So the notion is you install a server called Site Hub that manages a fleet of Spots in your industrial facilities. Spot lives on a dock, so it's completely autonomous. It can get up, go and collect data. You can manually drive it around to collect data. It carries enhanced sensing payloads, including IR imagery payloads, kind of improved audio collection capabilities. And if it's if it discovers a problem when it's out on its rounds, it can generate an alert that shows up on your phone or in the browser, saying that you need to pay closer attention to what's going on in your plant. So here's another example of that end-to-end solution in action. This is at a beer plant we tested at. So here again, we're showing the mobility of Spot descending open riser graded stairs. Here it's kind of safely navigating with some margin around an obstacle that wasn't in the map when it was recorded. Going through kind of narrow spaces, traversing obstacles that were laid out on the floor. and then collecting data. So there, the flash is just feedback saying that it's acquiring an image. And it can do that, as many times as you want. The robot's time is free, essentially. You can even walk through beer without slipping. It's a good feature. And here we're just showing all of the aiming is done autonomously of that pan tilt zoom stage on the robot. And here we're showing that that's being driven using machine learning models that have been trained on gauges to get you kind of like a perfectly cropped image of a gauge. So platform needs partners. We're not the only one trying to put together solutions with Spot. We have a number of customers that are doing the same. They're kind of clustered in a variety of ways, either by industry, such as construction, or their sensor providers, or they're trying to provide computer vision smarts for Spot. Before I close, I just wanted to mention some other applications of Spot. There's lots of things that left out today. In particular, there's like a whole branch of applications that are really taking off now with the arm on Spot and manipulation. But I wanted to spend some time on some fun ones because I think they're pretty interesting too, and actually pushed our robotics capability quite a bit. The first idea is this notion of putting Spot into the hands of consumers. Although it's been built as an industrial device, whenever we bring Spot out into the public, they're kind of enamored with it and they want to get their hands on it and drive it. So this was a project we did with Twitch, where they took over an abandoned warehouse, kind of remodeled it as a big gaming area with mazes and obstacles, and then they had their celebrity Twitch streamers race spots through this course. And I think it's a really interesting idea. I think Formant has also done an experiment where they get people from the general public to drive Spot. And I think it will go a long way to building a positive perception of our types of robots and really kind of lay the groundwork for a world where our kinds of robots are more prevalent, including in people's homes. There you can see someone boldly jogging up onto a platform. So it's not just interactive applications in the entertainment space. We've also been heavily interested in using Spot as an actor to express emotion. So here you can imagine Spot is dancing to some sort of waltz music. And what's incredible about this is that a lot of this motion was crafted by animators and tools that animators love and understand, like Maya, and then interpreted on the robot using optimal control tools. And so, each one of these motions, these clips, these primitives in this dance, 4 years ago would have taken a controls engineer a couple of months to perfect. And now with the tools that we have developed for this, we can quickly iterate on these motions with an animator, and controls engineers kind of out of the loop. I'm just going to let this play for a while because I think it's really does a great job of showing off Spot's agility and the expressiveness of its range of motion. We're not the only ones that have done animation with Spot. So this is a video from last summer. Basically, during the pandemic in the the Major League Baseball in Japan, they couldn't have fans. So, they were figuring out ways to add interest to their games. So they created, a seventh inning stretch routine with 20 spots. We're always in the product world worried about reliability, but Spot, these 20 spots basically went through the whole season without an issue, even though they were used pretty heavily to do this stomping dance. I encourage you to go online on YouTube to listen to the music. It's quite invigorating. Yeah, this was a fun push for the team to help this team achieve this performance. So I'll leave it there. And, like some of the others mentioned, we're hiring too. So, if you want to live either in the Bay Area or in Waltham, Massachusetts, we're hiring. So let us know. This is a costume we built for Spot with programmable LEDs. It had a microphone so it could react to music. Kind of fun thing that an artist did with Spot.
Thanks a lot, Marco. That was very nice. Very nice talk. I think the only question that it came up, and it was also my question, is there any environment that Spot is now, it's challenging for Spot basically, and cases that it may not be as reliable as in the cases that you showed in the videos.
Yeah, I think challenges that remain are really in kind of semantic understanding, I would say, of the environment for Spot. There are still instances where the operator has to provide hints like, you're going on a graded surface or you're going on stairs here. And other areas where the robot's perception isn't good enough to know that it could potentially be a problem, like negative obstacles. So I think those are challenges that we're looking at. Fortunately, they're not like roadblocks to actually getting Spot out there in an application.
All right. Okay. Thanks a lot again. I think we need to move to the next talk. We really appreciate your talk on Spot.
Thank you.